Hello, knowledge seekers. In this episode of 20-Minute Books, we delve into Brief Answers to the Big Questions, a thought-provoking work penned by the esteemed theoretical physicist Stephen Hawking. This posthumous publication brings to light Hawking's reflections on the most profound inquiries of our existence. Navigating through the vast expanse of the cosmos, the narrative voyages from the genesis of the universe to the enigmatic depths of black holes. Moreover, it casts a contemplative eye on human endeavors in space exploration and contemplates the potential risks posed by artificial intelligence. Considered an intellectual giant, Stephen Hawking served as the Lucasian Professor of Mathematics at the University of Cambridge and is widely recognized for his groundbreaking contributions to science. Though he passed away in March 2018, his legacy endures through his writings, which continue to dazzle and educate. Brief Answers to the Big Questions is the quintessential read for anyone enthralled by the mysteries that preceded the Big Bang, for those seeking to unravel what lies behind the event horizon of black holes, and for individuals vigilant about the future challenges that superintelligent AI may bring. Join us as we tribute Hawking's genius and explore the grand wonders of the universe through his brilliant perspective. Brief Answers to the Big Questions. Hawking's final thoughts on the biggest questions facing humankind. Introduction. Explore the cosmos through the mind of Stephen Hawking. Imagine scaling a mountain of mysteries, each step taking us closer to understanding the essence of our universe. This is what it feels like to journey through the thoughts of the late Stephen Hawking, a scientist who spent his life unraveling cosmic puzzles. Brief Answers to the Big Questions serves as a testament to Hawking's intellectual might, blending the profound with the accessible as he contemplates the very fabric of existence and our place within it. As we dive into Hawking's explorations, you'll encounter the enigma of black holes, gravitational giants where not even light can escape. They're similar to behemoths like Niagara Falls, except instead of water plunging into an abyss, it's reality itself that's being pulled in by unfathomable force. Delve into the idea that right here, within our own solar system, moons like Europa orbiting Jupiter may hide oceans beneath their icy crusts, inviting us to ponder the tantalizing possibility of life beyond Earth. Beyond these mysteries, Hawking casts his gaze upon humanity's potential futures, illustrating an initiative that might revolutionize space travel by employing light sail technology, the ability to traverse the stars powered by nothing but light. This thrilling concept beckons us to consider a future where humanity spreads its wings into the vastness of the cosmos, driven by ingenuity and the unending quest for knowledge. Part 1. The Cosmic Conundrum, Reconciling Science and the Divine. A quest as old as civilization itself, humans have forever sought to make sense of the cosmos and their role within it. It's a tale of two narratives, one steeped in the spiritual, another grounded in empiricism. In one camp, human life is imbued with purpose by divine will. In the other, existence is a fortuitous cosmic event. The gulf between science and religion appears vast, each standing firmly by their disparate revelations. Our innate drive to decode the universe's secrets has historically been sated by religious accounts, invoking deities as the architects behind natural phenomena like storms and eclipses. Contrast this with the scientific perspective, where the universe is likened to a colossal machine, with every cog turning in accordance with unalterable natural laws. Consider the example of a tennis match. Every swoop of the racket, every arching ball that sails over the net is an illustration of these laws at work. Gravity, motion, they function without fail, processing every variable, from the strength of a serve to a gust of wind, and yield a predictable result. These laws are both immutable and omnipresent. They shape the parameters of everything, from the humble motion of our tennis ball to the majestic orbit of planets. Their consistency is so absolute that even the hypothetical concept of a God would be powerless to bend them. This leads us to a potential bridge between science and divinity. If God were defined not as an all-knowing creator, but as the embodiment of these fundamental laws, then perhaps religion and rationality could find common ground. Einstein himself often referred to God not as a personage, but as a symbol for the observable, unwavering principles governing the universe. Yet, to many, this reconciliation falls short. The longing for a God with whom one can have a personal relationship is deeply ingrained. But when we stand amid the vastness of the universe and measure the seeming insignificance of human existence against it, the likelihood of an omnipotent creator feels increasingly remote. This provokes the ultimate query. If the traditional narrative of creation is questionable, then how did the universe come to be? This is the conundrum that challenges us to look further, to dig deeper, and to contemplate the origins of everything with fresh perspectives fueled by curiosity and boundless wonder. Part 2. Why the origins of the universe defy the concept of before. Picture the universe's inception, an event of immeasurable magnitude that we've termed the Big Bang. Teetering on the edge of human comprehension, it's the very cradle of cosmic existence. In this awe-striking model, existence blossoms from something minuscule, an entity so compact it might be dwarfed by a single proton, then unfurls to become the vast universe that surrounds us, an expanse that keeps broadening even as we speak. Edwin Hubble, an astronomer whose name now graces a space telescope, played a pivotal role in our understanding of this expansion. In 1929, through meticulous observations, he discovered an astonishing fact. Galaxies are drifting apart, their separation speeding up with distance. This revelation pointed to a universe that started as a singularity, a point of infinite density where all matter was one. Support for the Big Bang came thundering through the cosmos in 1965, with the unearthing of faint microwave radiation, echoes of a hot, dense origin story for the universe. But this brings us to the confounding issue of what preceded the Big Bang. And here, Einstein's groundbreaking vision of space and time as a woven fabric, a four-dimensional plane known as space-time, transforms our grasp of cosmic chronology. Within this fabric, enormous masses can cause distortions, akin to how a bowling ball would warp a held-out blanket. But push these distortions to their extreme, say at the heart of a black hole, and time itself seizes up, refusing to tick forward. Our minds balk at what happens as we rewind to the beginning, at that nascent singularity, simultaneously the heart of all things and a point of nothingness. Classical physics crumbles. Space and time meld and twist until they're meaningless by our ordinary standards. In this realm, or lack thereof, the concept of a before is nonsensical. In a space devoid of time's march, causality loses its grip. Everything we know insists that actions have precursors, yet here where time ceases, any prior event, any cause, cannot exist. It's a testament to the vastness of what we don't know, a tantalizing gap in our universal understandings. With the mind still reeling at the thought of a beginning without a before, let's pivot to an enigma that perennially captivates our species: the existence of life beyond Earth's atmospheric shores. Part 3. Alien Life, Separating Science Fiction from Scientific Probability. The possibility of alien life has always tickled the human fancy, gracing our screens and pages with a pantheon of extraterrestrial beings. Among these visions of strange and wondrous creatures, the pressing question arises: does intelligent life exist elsewhere in the vastness of space? The quest to answer this teases the intellect and challenges our conception of life's rarity. Earth, our home, suggests a promising prospect. Life emerged here rapidly, a mere 500 million years after conditions became favorable. If we consider the universe's age, a grand 7 billion years at Earth's formation, the stage seems set for countless other civilizations to have come and gone, their legacies dissolved in the cosmic tide before our ancestors even struck flint to kindle flame. Consider the candidacy of habitable planets. Current estimations propose that 1 in 5 stars hosts a planet in the so-called Goldilocks zone. Not too cold, not too hot, just right for life to take root. By these numbers, our own spiral arm of the galaxy could be teeming with potential Earth twins. A staggering 40 billion opportunities for life as we know it. But if alien civilizations are plausible, their conspicuous absence looms large. Why, in the immensity of space and time, have we not crossed paths? One hypothesis posits the abundance of life but the scarcity of intelligence. Life on Earth lingered in unicellular simplicity for 2.5 billion years before giving rise to complexity. Intelligent life demands time, a commodity finite and subject to the whim of cosmic events. Consider the cataclysms that might snuff out nascent civilizations. Earth has been mostly spared since the asteroid that doomed the dinosaurs 66 million years ago, but such impacts are ticking cosmic time bombs, with an anticipated earth-shaking event every 20 million years or so. Our evolutionary journey may be a lucky throw in a dice game where the stakes are existence itself. For other life forms across the galaxy, the outcome might have been less fortunate, leaving behind silent worlds, testament to life's fragility, in a universe indifferent to its survival. This interplay of chance and time leaves us suspended between what we can imagine and what we can observe. The prospect of encountering the alien, ever alluring and ever elusive, continues to animate our collective curiosity and spurs us onward in our quest for cosmic companionship. Part 4. Peering into the future. Science's limits and the allure of prediction. The concept of foreshadowing tomorrow holds an irresistible charm. Who wouldn't be tempted by the power to foresee what the future holds? It's a power nestled deep within human fascination, the ability to anticipate the outcome of a lottery, to outsmart fate, or to navigate life's many crossroads with the prescience of a seer. The pursuit of predictability has ancient roots, yet scientifically speaking, the answer to whether we can foretell future events oscillates between unlikely and under very specific conditions. This inquiry drives us into the realm of deterministic theories, where every occurrence leads to the next, in a chain of cosmic dominoes. Enter Pierre-Simon Laplace, with the notion that knowledge of all particles in the cosmos, their locations, their velocities, would unlock the power to predict the universe's future events. Picture your car speeding down the highway. If we know its current speed and position, we should be able to tell where it's going to be half an hour later. This deterministic stance, a pillar of classical physics, however, found itself at odds with the revelations of the quantum world. Werner Heisenberg, with his uncertainty principle, argued that pinpointing both position and momentum of particles was a Herculean task, shrouded by the intrinsic fussiness of quantum behavior. The upshot was quantum mechanics, a formidable framework for explaining the atomic and subatomic realms. Here, particles flit about with a touch of indeterminacy, their existence encapsulated by wave functions that designate probability rather than precision. These functions are esoteric arrays of numbers, painting a picture not of certainties but of likelihoods. Yet even quantum mechanics, with its probabilistic provisions, hits stumbling blocks. The theory, so adept at handling the microscale, sputters when it encounters the ferocious warping of space-time within black holes. The dream of predicting the future, as envisioned by classical science, is confronted by quantum reality. A universe that operates less like a clockwork and more like a game of chance, with rules we are only beginning to grasp. This cosmic coin toss governs particles in a way that distances us from prediction and surface an uncomfortable truth. The future may forever dance just beyond the reach of our loftiest calculations. Part 5. Black holes. Enigmatic, not entirely inescapable. Picture yourself aboard a spacecraft, charting the cosmos under the command of an over-eager captain whose navigational mishap has set you on a collision course with one of the universe's most enigmatic phenomena, a black hole. As you're inexorably drawn toward this celestial anomaly, a bitter comfort presents itself. You may be the first to witness the secrets beyond the event horizon, albeit at the precipice of your doom. The genesis of black holes lies in the death of colossal stars. These titanic furnaces, awash with mass, also bathe in gravity's pull. Normally, a star like our own Sun fends off gravitational collapse by burning nuclear fuel, fusing hydrogen into helium, generating the pressure needed to push back against its own weight. Alas, this fiery dance can't last forever. When a star exhausts its nuclear reserve, it succumbs to gravity, imploding to a singularity, an infinitely dense point where the known laws of physics crumble. The singularity remains shrouded in mystery, veiled by the black hole's event horizon, a boundary beyond which even the fleetest particles, photons of light, cannot defy gravitational imprisonment. Imagine the event horizon as a cosmic Niagara Falls, a point of no return. Approach it, and you may still fight the pull. Cross it, and the descent is inescapable, or so it was thought. In the cosmic tapestry etched by time, you might expect the universe to be brimming with these insatiable voids. Yet, it appears they are not as inescapable as once believed. The revelation came from Stephen Hawking in 1974. He proposed that black holes are not black but have a temperature and consequently emit radiation. A paradoxical concept, considering their seemingly unbreakable grasp on all that approaches them. Quantum mechanics offered a clue. The void of space is teeming with virtual particle-antiparticle pairs that spontaneously emerge and annihilate. Yet when such pairs appear at the cusp of a black hole's event horizon, one particle may fall in while the other escapes, leading the black hole to gradually shed mass, shrink, and, over unimaginable eons, evaporate. It's a startling testament to the interplay between the cosmic and the quantum, asserting that even the universe's mightiest vacuum cleaners do not operate in perpetuity. Take a moment to absorb this profound nuance of nature, and as we do, let's turn our gaze to ponderings about the future of our species. Part 6. Earth's future hangs in the balance. What we can and cannot control. As we pivot from the cosmic canvas to the canvas of our own world, we're met with a striking realization. Earth, our only home, is facing an assemblage of threats. These perils are twofold: the inevitable cosmic phenomena that fall beyond our control, and the anthropogenic crises we have the power to mitigate. Take, for instance, our planetary gamble with celestial debris. By the merciless calculus of astrophysics and probability, Earth's next great asteroid impact is a question of when, not if. It's a sobering thought, one that underscores our vulnerability in the vast cosmic arena. However, staring into the void of inevitability shouldn't paralyze us. Rather, it should sharpen our focus on the crises that humanity can actually confront. Climate change is at the fore, a product of our industrial endeavors, now ushering in a cascade of environmental upheavals. The ocean, once a stabilizing force, now threatens to amplify global warming by releasing vast amounts of trapped carbon dioxide. Shrinking ice caps diminish the Earth's albedo, its reflective shield against the sun's warmth, exacerbating the greenhouse effect. This cycle is a clarion call for innovation and policy reform to steer away from the brink of runaway climate change. Failing to do so could transform Earth into a hellish tableau reminiscent of Venus, with scorching heat and corrosive rainfall far removed from life as we know it. Another specter looms, the human-crafted specter of nuclear doom. The geopolitical landscape may wax and wane in tension, but the threat is perennial. The planet hosts an arsenal with unthinkable destructive capability, a sword of Damocles hanging over modern civilization's head. Nuclear proliferation, the risk of rogue nations harnessing this apocalyptic power, and the nightmare of such weaponry falling into the hands of terrorists render this issue urgent. The international community must strive for disarmament, diplomacy, and secure containment to avoid catastrophes of our own making. Considering these formidable challenges, one prediction seems grimly plausible. The Earth may well stand on the precipice of ruin within the next millennium, through either natural catastrophe or self-inflicted wounds. Yet hope persists that human ingenuity will prevail, that we'll develop the technology not just to evade disaster, but to transcend our earthly constraints. This innovation could be our lifeline, enabling future generations to continue the human story beyond this fragile blue orb, charting new courses among the stars. Part 7. Space Colonization. A New Horizon for Humanity's Exploratory Spirit. Picture a time when a daring voyage changed the course of history. The year is 1492, and Christopher Columbus sets sail, embarking on an expedition that would redefine our understanding of the world. Fast forward to our present day, and we stand on the cusp of a similarly transformative era, the era of space colonization. In the current global landscape, space exploration often takes a back seat, succumbing to the fiscal scrutiny and political calculus that deem it less pressing amid earthbound concerns. This is in stark contrast to our innate drive for discovery, that quintessential human trait that impels us to venture beyond the known. Human history tells us that progress is often made in leaps, sparked by deadlines and daring goals. Consider the Apollo missions, born of President Kennedy's charge to send man to the moon within a decade. A vision that captured hearts and ushered in a golden age of scientific advancement. With the technology we possess today, the ambitions of establishing a lunar base by 2050 and orchestrating a manned expedition to Mars by 2070 are not flights of fancy. They are attainable milestones that can reignite our collective excitement for the final frontier. Our aspirations need not be earthbound, nor confined to our immediate celestial neighbors. The icy shell of Europa, one of Jupiter's many moons, beckons with the promise of subterranean oceans that may harbor life. Such a discovery would be a monumental testament to the diversity of life-sustaining environments. Yet, our longing to reach beyond our solar system faces a formidable obstacle: the vastness of space. Alpha Centauri, our celestial next-door neighbor, lies a daunting 4.5 light-years away. This distance renders journeying there with conventional rockets an odyssey extending beyond human lifespans. Potential solutions, like nuclear fusion or the more science fiction-esque matter-antimatter annihilation, remain elusive prospects for the distant future. But there's a silver lining: unmanned missions, pioneered by initiatives such as the ambitious Project Starshot. This concept envisions sending a fleet of nanocraft, outfitted with light sails and powered by focused beams of laser energy from Earth, soaring to the stars at unprecedented speeds. While engineering challenges are plenty with such futuristic endeavors, they're not beyond surmounting. This spirit of ingenuity is a hallmark of human progress, a reminder that our insatiable curiosity, when channeled through the crucible of innovation, can transform the boundaries of possibility, carrying us into new realms of exploration and discovery. Part 8. The Double-Edged Sword of Artificial Intelligence. The narrative of technology outpacing humanity, Skynet, achieving sentience and dispatching its cybernetic assassins, is a narrative etched into the popular imagination. Yes, it's the plot of a blockbuster movie, but strip away the glitz, explosions, and Hollywood theatricality, and you're left with a kernel of truth that merits serious contemplation. The concept of artificial intelligence slipping the leash of its creators is not just fiction. It's a plausible extension of current technological trends. The evolution from bulky, room-sized computers to sleek smartphones is testament to the rapid pace of our digital revolution. Currently, our intellectual capabilities vastly exceed those of any artificial system, but the gap is closing, and closing fast. Consider artificial intelligence as defined by adaptability, the capacity for a system to learn from experience and modify its own behavior. A self-improving AI could vault swiftly from underfoot to overarching, leaving us biologically bound creatures trailing in its wake. Yet the risks should neither be hyperbolized nor dismissed. AI, harnessed judiciously, has transformative potential. It could be our ally in conquering disease, in alleviating poverty, and in achieving scientific breakthroughs currently beyond our wildest dreams. At present, technological marvels like autonomous vehicles and complex game-playing algorithms revel in the spotlight. But Moore's law, the observation that computing power typically doubles every 18 months, hints at a horizon brimming with possibilities and perils alike. The specter of an AI surpassing human intellect within the next century is no longer relegated to the realm of science fiction. It's a scenario that commands foresight, preparation, and perhaps, above all, prudence. Fortunately, this is not an uncharted territory. Visionaries like Elon Musk and Stephen Hawking, backed by a chorus of leading minds, have sounded the siren. The field of AI ethics expands, scholarly grappling with these dilemmas and how we might ensure, as we step boldly into the future, that our silicon progeny remains staunchly at the service of their makers. The crux of the matter in this technological odyssey is that we cannot retreat from our creation, but must instead steer it with care and consciousness. We must sow the seeds of a future where AI remains an extension of human will, an instrument not of domination, but rather of enhancement for the betterment of all humankind. Final summary. In the grand tapestry of existence, humans have tirelessly sought understanding, crafting narratives and theories to decode the profound questions of our origins and purpose. This enduring quest has unshackled us from the myths of old, propelling us into an age where the immutable laws of physics guide our understanding of the cosmic machinery. The insights gathered from the cosmos serve as humbling reminders of our place within it. From the raging torrents of black holes to the potential for life on distant worlds, our intelligence has grasped phenomena once relegated to the realm of the gods. Yet, as we probe deeper into the universe's enigmas, we're also turning the lens inward, scrutinizing the existential challenges that beset our own planet. The countdown has begun, with climate change upon us and the specter of nuclear conflict lurking in the shadows. We're at a crossroads, one that necessitates immediate action and bold initiatives, such as setting our sights on the colonization of space, to safeguard not just our survival, but the unrelenting spirit of human discovery. Artificial intelligence, a creation of our own ambition, emerges as a powerful tool, but also a potential harbinger of unintended consequences. Balancing innovation with ethical foresight is key to ensuring our technological ascent enables progress without compromising our dominion. In this crescendo of exploration and existential urgency, we're reminded that our pursuit of knowledge is not just an endeavor of curiosity, but also one of stewardship. We stand as the custodians of our home, Earth, even as our eyes remain fixed upon the stars, always searching, always yearning for answers in the infinite expanse. Thank you for joining me today on this journey of learning and discovery as we explored the insights of another thought-provoking book in our growing library of knowledge. If you've enjoyed our time together, please take a moment to follow our podcast, give us a 5-star rating, and share 20-minute books with other knowledge seekers. Your support truly means a lot. Don't forget to join me again in the next episode, where we will delve into another enriching book. Until then, happy reading and happy listening.